Hello friends, welcome to our channel Knowledge Amplifier, and this is my second video tutorial where in my first video I have discussed some part on the algorithm which actually works behind the creation of regression tree. Because as I have discussed earlier also, suppose I am having this small data set and I want to predict a student's final exam score based on total number of hours the student has studied for each day and his or her midterm score. Okay, then suppose we are creating one decision tree. We have suppose got this kind of decision tree. So how our algorithm is deciding which particular input feature has to be selected for splitting and what value has to be selected, right? So for that, what I have told you, let me go to PowerPoint presentation. So here I have discussed this earlier also. So midterm and hours are my two-dimensional space, and for distinct values are taken. Then what it will do, it will consider all the input features, or we can say predictors, okay, and all possible cut points. Okay, so suppose for hours, okay, so first it will consider this cut point 5. So it will cut our whole data set into two parts, left and right. So what is the residual sum of square difference it will calculate. Similarly for 6, 7, 8, 12, 14, 18 it will calculate for all this, and this is only for hours feature. Similarly for midterm feature it will calculate like this. So for all this combination, whatever minimum residual sum of square error we are getting, our model is going to choose that particular predictor and that particular cut point, okay, for splitting our data set. Like suppose after all possible combination, suppose we have got for hours equal to 11 when we have splitted our data set like this way, okay, in left side and right side we have got R5 as residual sum of square error, and suppose that one is minimum. So what it will do, it will consider that as our first splitting criteria. So in the final step we will be getting like this. Our dataset is now divided into two parts. Now for each individual part, again same algorithm will be implemented. Okay, like consider the left hand side only, don't consider the right hand side. Left hand side is a separate region, right hand side now become a separate region. So 5, 6, 7, 8, 4 possible hours and all these possible midterm scores. So it will again first split based on hours equal to 5, then hours equal to 6, then hours equal to 7, then hours equal to 8. Similarly, for midterm score equal to 35, 40, 42, 45, 50, 60, 65, 75, 80, 82, for all this it will split. And it will again check for which splitting I am getting minimum residual sum of square, or we can say RSS, residual sum of square minimum, and that one for which we are getting for which predictor we are getting minimum residual sum of square for a particular cut point value, that it is going to choose for the splitting criteria in this region, and separately it will apply the same algorithm in this region also. Okay, like this our algorithm will proceed, and eventually we will be getting this kind of beautiful decision tree. Okay, so if I just summarize the whole algorithm, the steps can be broadly classified into 4 points. Okay, first, consider all predictors, that is input features, and all possible cut points. Okay, like I have told you, hours equal to 5, hours equal to 6, hours equal to 7. Similarly, midterm score 42, 65, 35, all this. Okay, calculate residual sum of square error for each possibility. Okay, calculate residual sum of square for each possibility and select that particular predictor and that particular cut value corresponding to that particular predictor for which you are getting least RSS. Okay, now you might think, okay, fine, so after implementing after getting the first step, we have got these two regions. Now again in this region, left side region and in the right side region, we will apply the same algorithm from the beginning. But when our algorithm should stop, what is the stopping criteria? Like that you should understand also. So it will continue till the stopping criteria is reached. Now we have to understand what should be the stopping criteria. There are majorly 3 stopping criteria is present. Simplest one is max depth. Okay, so you can see here depth is 2. One layer like this one, another layer is this set. Okay, so depth of our tree is 2. So now you can specify while creating the model what you want to get the maximum depth for your decision tree. Okay, and the model will stop if it reaches that particular depth. It will not split further. Okay, so this is one stopping criteria, that is max depth. Another stopping criteria is, minimum observations at leaf node. Suppose we are specifying the leaf node minimum number of observations should have 13. After splitting one node, we are getting in one leaf 20, in another leaf only 5 observation we are getting. So that particular split will not be considered. Okay, so try to understand minimum number of observation you can specify that should have in the leaf node. These are called leaf node, that is outermost or bottommost part in our decision tree. Okay, this is our leaf node. Suppose while creating the model we are specifying that it should not be total number of observation in leaf node should not be lesser than 10. Now suppose after splitting based on hours we are getting in this particular leaf node we are getting 2. Okay, that time it will not split, it will not consider that as split, right? So this is, I hope you can understand, minimum number of observation in leaf node you can specify. Another one is minimum observation at internal node. Okay, so what is that? Suppose I am specifying minimum number of observation at least should be 20, then only you can proceed further. Now suppose after this splitting based on hours in this particular node we are getting only 3 observation, then obviously it is lesser than minimum number of observation the internal nodes should have to go to further splitting, right? Whatever we are specifying, so it will not split further, right? So these are majorly 3 criteria: minimum number of observation in the internal node. So what it will do, it will basically this much minimum number of observation is required in the internal node, then only it will go for further splitting. Then minimum observation at leaf node. Okay, so after splitting this much observation at least should be present in the leaf node, otherwise it will not split further. And maximum depth, it will not go more than maximum depth whatever you are specifying. So these are majorly 3 splitting criterias in case of creation of regression tree. So I hope you have got an intuitive feeling how our regression tree algorithm actually works. Okay, so this is all for this video. Don't forget to check my first video. The link I'll be providing in the description box, and the MATLAB implementation also I have discussed. If you want, you can check that video also. Link will be provided in the description box, right? So this is all for this video. If you find this video helpful, please like, share and comment. Subscribe my channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of my latest videos. Thank you.